All right, moving forward, we're going to talk about the surface area of pyramids and cones now. Again, the definitions are exactly the same. The only difference is you're only going to have one base to add to the lateral surface area on these. So with pyramids first, we'll look at and we'll look at what everything means to. Your lateral surface area is going to be big P, and then this, it's an italicized L all over 2. And up here, let's go ahead and define what this is. This means the slant height. It's going to be the height of the face. Okay, it's going to go from the tip down the wall to the base, and you'll see that here in a minute. Your total surface area is going to be that P, which we already know is perimeter base, times slant height over 2, but we have to add in the base, the area of that base now. But again, we only have one base. So let's take a look at our first guy here. All right, our lateral surface area, remembering that this is perimeter base times slant height divided by 2. So let's go find, we know we're going to have to find big P, we know we're going to have to find big B. First, let's go ahead and talk about that slant height. Right here, sliding down the side of that wall, this is going to be your slant height, okay? So let's go find perimeter. Well, the perimeter here, we're only listed as 10, so we're going to have to go ahead and say this is a square pyramid. So all sides are going to be 10. So we have 4 sides times that 10. Big P is going to give us 40. Big B, we're just going to square 10, your side squared. So B is going to be 100. So let's go ahead and plug in for right here. For our lateral surface area, we're going to have the perimeter. We're going to have everything over 2. Perimeter of base, 40, times the slant height of 13, all divided by 2. And when we get this, we're going to wind up with a total of 260 units squared. Again, we don't have centimeters, inches, or anything. Just call it units. Area is always squared, whether it's area or surface area. Total surface area over here, the perimeter of base times slant height divided by 2 plus 1 big B. So we have our 40 times slant height 13 divided by 2, and we're only going to add 1 big B, 100. Well, honestly, this was the first part, right? We just add 100 to it. We're going to end up with 360 units squared. So we're going to have to do a little extra on this next guy, triangles. They're our friends, right? We have a regular triangular pyramid with base edges of 24. Regular means all sides are congruent, okay? So each one of these is going to be 24. You got your congruent markings also, all right? And here we got 24 here. I'm not going to mark it in the back, though. But all 3 sides are going to be 24. So we can automatically find big P here. Big P, we have 3 sides, all 24. Big P is going to end up being 72. All right? We can see our slant height right here. All right? And it tells us up here that our slant height is 16 inches. So right here we could say slant height with that weird looking L is 16. Now, to find the area of the base, okay, again, area of the base for a triangle is going to be your base times your height. Problem is that we don't have that height. We're going to have to do the same thing we did on the prisms with the triangular prism, and we're going to have to find that. So we're going to take this triangle to the side, okay? We take this guy right here to the side, one of these triangles, knowing that this right here is going to be 12 because the other side is 12. These are going to be congruent, okay? So let's go ahead and pull this guy to the side. We have 12 down here. Let me draw that a little bit better for you guys. We have 12 down here. There's our 90-degree angle. And then the hypotenuse is right here, that 24. So we're looking at what's on the ground here, okay? So this is 24. We know that that's going to be our C. So again, I'm just going to use H for height. We're going to have our height squared right here, plus 12 squared equals 24 squared. Please pause it, okay? Before that answer pops up, I want you to work it on your own. And again, done Pythagorean theorem way too many times. You may have noticed we did get a decimal. We're going to round to the nearest tenth, 20.8. So let's go find big B now. Big B, base, whole base, okay, 24, times the height that we found was 20.8, divided by 2. Big B will come out to approximately 249.6. So let's go substitute in for our formula. Perimeter base times slant height divided by 2. So we have the perimeter, which was 72, times the slant height of 16, divided by 2. We calculate that in our calculator. We get 576 units squared. Next, we're going to take that perimeter of the base times slant height divided by 2, the lateral part, and we're going to add the single one big B base that it has. Times 16 over 2 plus big B, the approximate 249.6. So we're going to add that, and really all you have to do after finding lateral is just add the base, and then you've got it. So if we add that 249.6 to 576, we're going to end up with 825.6 units squared. Next, we made this very easy for you guys, okay? Usually you have to find the area of the base. We're giving you the area of the base on this one. You'd have to do the apothem times the perimeter divided by 2, but we gave you what we need. All right, first things first. The base edge is 6 centimeters. That means all of these sides right here. So this is 6 centimeters. The base area, look at that. They already gave us big B. Sweet. Is going to be 93.5, and that should say centimeters squared. It doesn't look like a 0.5. Now it does. And we have a slant height. They've given us everything we need except for that perimeter. Your slant height is going to be 14. So let's find our perimeter. Well, let's see how many sides we have. 1, 2, 3, 4, 5, 6 sides times the length of 6. Perimeter of the base is going to end up being 36. Again, you have big P, you have the slant height, you have the area of the base. Please pause it and work this out on your own. Here's our formula for lateral. So we have perimeter of base 36 times slant height of 14 over 2. We get 252 centimeters squared. Told you we're going fast on this one. You should have paused it and done it on your own. All right, total surface area. We have that lateral surface area, 36 times 14 over 2. We're going to add one single big B of 93.5, or just take the 252 and add 93.5. We will get 345.5 centimeters squared. Let's take a look at cones now. At cones. Again, same exact definitions. Just like the cylinder, the face is a curved face. Just like the pyramid, it only has one base. So your lateral surface area, it's going to be nicer than the cylinder, is just going to be pi times the radius times the slant height. That's it. Your total surface area is going to be that lateral surface area of pi r slant height, but you're going to have to add the area of the base, which is just a circle, which is pi r squared. Okay? So let's take a look here. Radius and slant height. Those are the only two things we need in here. Okay? Radius they gave to us is 15. Slant height they gave us 25. Nice, sweet. So all we have to do is substitute in. Lateral surface area, pi radius, slant height. So pi r, weird looking L. So here we get pi, plug in 15 for the radius, 25 for the slant height, plug it all in, we're going to round to the nearest tenth. We should get 1,178.1 as long as my calculations were correct. Total, we're going to have pi times radius times slant height plus pi r squared. So here we go. Pi, plug in the radius, plug in the slant height, plus, we're going to run out of room, pi times radius, do not forget to square it. Okay? Or you could just take your lateral surface area, 1,178.1, and add pi r squared. And we're going to wind up with 1,885. We're going to put our units squared. Because technically you are supposed to be labeling these. All right, the next one we're going to have to do a little bit of work here. What I want you guys to notice here is they gave us the height of the cone and the slant height. They didn't give us the radius, they didn't give us the diameter. But what do you see there? A triangle. So we're going to take this triangle right here. We're missing the radius. We draw it off to the side next to this little fox. We have 45 right here, 51 right here, and here's our radius. So the radius is one of the legs. So I'm going to put down here radius squared plus my other leg, 45 squared, is equal to the hypotenuse, C, 51 squared. Again, you are going to pause this. You're going to do this on your own. If you get a tenth, I'm going to tell you right now, you're not going to get a decimal. It's going to be a whole number. Please pause it now. We should have come up with 24 for our radius. And I went ahead and labeled it in the blank. Slant height they gave us was that 51. Hard part's over. Let's go plug in. Lateral, pi times radius times slant height. Plug it in. Pi times 24 times 51. Pause, plug in your calculator on your own. Use the pi symbol, not 3.14. We should have come up with 3,845 and 3/10 units squared. Yeah, started using the math. Pi times radius times slant height plus pi radius squared. All right, substitute in pi radius of 24, slant height of 51, plus pi, your radius squared, 24 squared. Or just add pi 24 squared to 3,845.3. Hoping that you've paused it and calculated it on your own. 5,654 and 9/10 units squared. Again, if my math is correct. If not, you should know because you should have calculated it. Last one, again, we want to show you the cone in a different position, as well as we want to show here that we actually have our diameter. Okay, so your diameter is 14.8, making our radius 7.4. Half of it. Don't want the diameter, we want the radius, 7.4. Slant height, they gave to us 15. All right, pause it. Do it yourself. I know you can do it. We just did it twice. It's plugging in, it's multiplying, you got it. Please pause it. Do these on your own. I'm going to go very quickly in hopes that you paused it and tried it on your own. All right? Lateral, pi times radius times slant height. So we have pi times 7.4 times slant height of 15. We're going to get, you should have gotten, hopefully, again, my calculations are right, 348.7 centimeters squared. Total, pi radius slant height plus pi radius squared. Here we go, pi, 7.4 radius, 15 slant height, plus, I'm going to put it down here, pi radius of 7.4 squared. Or just add the base to the lateral that we already found. We should get roughly 520.8 centimeters squared. And those are the pyramids and the cone's surface area.